Hello all, welcome to Now You Know channel. In this tutorial, we are going to see how to implement LRU cache in Java. So LRU cache has four properties. So they are number one, it holds a specified number of elements only. Here the cache, we need to mention a cache size and it holds that many number of elements at a given point of time or less than that. So here I have taken a cache size of 5. I'm trying to add some elements to the cache. So put 1, put 3, 4, 5. So up to this, the cache is full. Okay, the cache is full after put 5 operation is completed. Now I'm trying to add one more element. At this point, the oldest element in the cache is 1. So to accommodate the new element, it will remove the oldest element and add the newest element towards the right. So whatever the elements present towards the right is the latest element. So this is the property number 2. It removes the oldest element and accommodates the newest element when in case of cache is full. Another property, this is the property number 3, is when accessing an element, existing element in the cache, so that element will be removed from the current position and added towards the right. So here 3 is present in this position, right? So it has removed from this position and added towards the right. Similarly for get2. This is the property number 3. And the fourth property is when we are trying to put an existing element, which is 3 in this case, so we will be removing from the position and adding towards the right. So now for the implementation part. So I have already created a class here. So we will be needing a constructor with parameter size public and to hold this in an instance, we need to have an instance variable int size. And to hold the properties to hold the elements, we will be needing something that holds the elements of the cache. So here I'm going to take linked hashmap. I'm going to call this cache. I'm just going to assign the size with the size coming from the constructor, and I'm going to initialize cache with a new linked hashmap with size. Okay, linked hashmap of size. So this is pretty much about constructor that goes in the constructor. And now for the implementation of put logic. Public void put k key v value. So the simple expression to put the element in the cache is this dot cache dot put key and value. But before that, I need to check this property, right? When trying to add an existing element, that element should be evicted from the current position and becomes the latest entry. So to check this condition, I need to check whether the key is present in the cache or not. Cache dot contains key. Then I'm going to remove first this dot cache dot remove key and adding it back to the cache again. So after this operation is completed, I'm going to return from this point so that I should not perform the same operation again. So the another condition we need to check is when the cache is full, then we need to remove the oldest entry, right? So for that, I'm going to check this dot cache dot size is greater than or equal to this dot size. Then I'm going to remove the first element, and even though it is a linked hash map, we don't have the privileges like get first element or get the oldest element, but the workaround here is this dot cache dot key set dot iterator dot next, which gives the first element, which I'm going to assign to first variable, and then remove remove the first entry. So after removing the first entry, I'm just adding it. So the flow will come to this point and add it back to the cache. So if cache is not full, we just need to add, right? So this works. So that's all for put operation. And for get operation, public t get k key. So first condition you need to check is whether if the cache does not contains the key, we simply return null. Contains key, we simply return null. Otherwise, we will take the value. Sorry, it's a v, right? Value this dot cache get. We are taking the backup so that we can return afterwards, and the condition, the property. So when retrieving an element, the element will become the recently used element, right? So for that, I'm going to remove cache dot remove and add it back. Cache dot put key and value. Yeah. So first, at the end, we need to return the value, right? Yeah. So first, we are checking whether the cache contains this key. If not, we simply return null. Otherwise, we are taking the backup of. Okay, we need to check. Sorry guys, there are some indentation errors. Okay. First thing first, we check whether the key present in the cache. If not, we simply return null. Otherwise, I'm taking backup of the value for the key and removing the entry from the cache and adding it back to this cache. And at the end, we need to remove the desired value for the key. So that's pretty much about the get logic as well. So for the testing part, I'm going to create an instance with a generic integer and string. I'm going to call LRU cache. New. LRU cache with size 5. And one more thing I wanted to do is I wanted to override this toString method to see the element positions, each element position basically. Override public string toString. This dot cache dot keyset dot toString. Yeah. So I'm going to system dot. I'm just printing the current elements in the cache. Println LRU cache. First, it should be empty, and I'm going to add some of the elements to the cache. LRU cache dot put 1, 2, 3, 4, 5. So I'm going to change these keys to different unique numbers. 4, 5, and 6. So I'm going to do some get operation as well. So get get 3, get 2, and I'm going to do a put operation again. and at each get operation I am trying to check the output. So now the expectation here is, so at this point we should be having the keys in this order: 1, 2, 3, 4, 5. And after this put operation is completed, so we should be having the key in this order: 2, 3, 4, 5, 6. And we did the get operation for get 3. So 3 will be added towards the right. So 2, 4, 5, 6, 3. And similarly for get 2 operation, after get 2 operation is completed, then we should be having we should have in this order. Sorry, it should be present in this, right? Yeah. And the sixth element, I mean the element 6 is coming again, so that we should get the element in this order: 4, 5, 3, 2, 6. So let's run this program and see whether it is working as per expected. And yeah, so initially we don't have any values in the cache, and we did some operations like put operations of 1 to 5. So after adding the 5 elements, so we got the elements in this order: 1, 2, 3, 4, 5. And here I'm trying to add the new element, which is 6, and the oldest element has evicted, which is 1 in this case, and the arrangement of the elements is in this order: 2, 3, 4, 5, 6, 2, 3, 4, 5, 6. And we did the get operation for 3, so get 3. So 3 will be added towards the right. Now the output is 2, 4, 5, 6, 3. 2, 4, 5, 6, 3. Similarly, after get 2 operations completed, so we got element arrangement in this order: 4, 5, 6, 3, 2. 4, 5, 6, 3, 2. And now we're trying to do put operation for the existing element, put 6. So in this, after put 6 operation is completed, so we got the arrangement 4, 5, 3, 2, 6. Exactly, it is present in this console output: 4, 5, 3, 2, 6. So that's all for this LRU cache. I hope you enjoyed watching this video and learned something from this video. If you like this video, please like, and for more videos like this, please subscribe to our channel. Thank you. Thanks for watching. Bye. Take care.